Hi, this is Ashley Field with test number 19, performing a cross match. So we have our patient here for the donor. We're going to be using a 21 gauge vacutainer butterfly. We need some other blood samples on top of our EDTA tube, so I'm going to be getting a few tubes. So I'm just going to take my vacutainer out. Have my tubes here. I'm just going to apply some alcohol to the site. I'm just going to fill my serum separator first. And then I'm just going to start filling my EDTA tubes. I'm going to be using 2 of these. Okay. All right. So we have all of our samples and we are done. Hi, this is Ashley Field with test number 19, performing a cross match. So we have our recipient patient here. He's going to be getting a blood panel on top of the other EDTA tube that we have. So we have a few different tubes that we need. I'm going to be using a 21 gauge butterfly and then a 3 ml syringe. I'm actually going to grab a bigger syringe for this. I'm going to use a 6 ml syringe actually, just because we're getting a little bit more blood. Alright, so we're going to apply alcohol to the lateral saphenous.
Good boy, Baxter.
Good boy. Okay. Just going to open up my butterfly.
Good boy, Baxter.
Oh, good job, buddy. Apply pressure, and I'm going to fill my serum separator first. And then the first EDTA tube. Okay, and then the last one. Okay, so we have our tube, so we are all set. Okay, so we're back with part of our test number 19 cross match. So we have our donor and recipient EDTA tubes right here, which are properly filled and labeled, donor and recipient. Our donor is going to be Fozzie and our recipient is going to be Brutus. So we're going to go ahead and spin these down so we can get the plasma and separate the red blood cells to start the washing process. So I have counterbalanced tubes that are equally for the volume, and we're going to go ahead and load these into the centrifuge appropriately. Switch those. Okay, so those are all balanced. I'm just going to make the tops are on. Okay, and we're going to spin these at 9,000 RPM, so that's set appropriately, and then we're going to do this for 5 minutes. All right, and that's gonna start, and we'll be back. Okay, so we're back. Our plasma has finished spinning, so I'm just gonna go ahead and take out. There we go. So that's nice and separated. So I am gonna go ahead and separate the plasma from the red blood cells so we can start the washing process. Just gonna put that one there. It's gonna fall. That one there. Okay. So I have 2 white top tubes that we're gonna transfer the plasma to. One is labeled donor, the other one is labeled recipient plasma. So I'm going to start with the donor plasma. I'm just going to take the top off. And so I'm going to gently suction off the plasma, not disturbing the red blood cells. Okay, I'm just going to transfer that to the white top tube. Okay, discard that pipette. Okay, and I'm just going to put that here, and then we're going to do the recipient. I'm just going to separate that. Okay, again, just gentle enough to disturb the red blood cells. Alright, discard that. Okay. Alright, so now we can start to wash them. So what we're going to do is we're going to add 3 drops of the red blood cells to each centrifuge tube that I have labeled recipient and donor again. So we're going to take 3 drops of the recipient and donor into their separate tubes, and then we're going to add, we've got some normal saline here that we're going to add, and that's going to be added just into a Dixie cup so I can draw it up with a pipette, and we're going to do 60 drops of the saline since we're doing 3 drops of that, the red blood cells into each, and then we'll spin those down, and we'll repeat that process 3 times until the red blood cells are completely washed. So I'm going to start with the recipient red blood cells that I have here. So I am going to take a new pipette. We're going to just take some red blood cells, and I'm going to do 3. So we got 1, 2, 3. Okay. I'm going to discard that pipette. And I'm just gonna pour the saline into a cup. And we're gonna do 60 drops of these. 6, 7, 8, 9, 10, 1, 2, 20. 30, 5, 6, 40, 50, and 60. Okay, so we've got 60 mLs of saline to 3 drops of red blood cells. So I'm going to leave that there, and then we're going to do the same thing for the donor. Just going to get a new pipette. Okay. Alright, so we got our red blood cells. Right, so again, we're going to do 60 drops of saline. So that's gonna be, looks like 2.5, so we cannot measure that next time. Okay, so we're gonna spin these down. I'm just gonna take these out. Okay, so we're gonna put those in here. And we're gonna do this for 9,000 RPMs, and this is gonna be for 5 minutes. And we're gonna repeat this 3 times. So we're gonna do that. Okay, set that for 5 minutes and we'll be back. Okay, so we're back. Our centrifuge is done, so we're gonna take these out and we are going to, you can see those nice and suspended. So we're gonna decant the supernatant. So I'm just gonna take a fresh pipette and I'm gonna section off the top, not disturbing the red blood cells at the bottom. Discard that, and I'm going to do the same with the other one. Alright. Okay, so we have both of those. I'm going to do the same thing. I'm going to add 60 drops, which is 2.5 mLs of saline. So I'm just going to draw that up with a syringe now that I measured that out off camera, so I don't have to sit here for that long. So I'm going to add 2.5 mLs to each. And this is the second time we're doing this, so we're going to do it one more time after this. So I'm going to have those there. I'm going to go ahead and centrifuge these again for 5 minutes. And we'll come back, do it one more time, and then we'll be done. Right. Okay, so we're back with the rest of the second spin. So I'm gonna go ahead and take this again, and we're gonna do the same thing. I'm just gonna decant the supernate and then add the 60 drops again, or the 2.5 mLs. New pipette and do the same with the recipient. Okay. And then we're going to add the 2.5 mLs of saline to each tube, or 60 drops. And this will be the last time we wash them. Okay. Alright, so we're going to add these again. Do the same thing for 5 minutes. And we'll be back. Okay, so our last wash has finished spinning, so we're going to go ahead and take this out so we can make our red blood cell suspension. Alright, so we are going to one more time just take off the top without disturbing the red blood cells on the bottom. Okay. Just do this to the recipient. Alright, so we're going to make our red blood cell suspension. So we're going to take a drop of the red blood cells from the wash to the 20 drops of saline. So we have 2 tubes labeled recipient red blood cell suspension and donor red blood cell suspension. So I'm just going to go ahead and open those up. And I'm just going to just agitate these a little bit. Okay, so I'm gonna take 1 drop of, just make sure I have recipient. Okay, so I'm gonna do donor first. So So we have 1 drop of the donor, and then we're going to take 20 drops of saline, which I have in here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 17, 18, 19, 20. Okay. So discard that. Alright, so that is our donor red blood cell suspension. So I'm just going to put that to the side, and then I'm going to do the recipient, which is the same thing. I'm going to take 1 drop of the washed red blood cells. Okay. Just going to grab 1 more pipette. So then I'm going to take 20 drops of saline for the recipient. Okay. Alright, so we have both of those. So now we can do our major, minor, and recipient cross match. So I'm just going to agitate these a little bit. So what we're going to do for the donor, I have, let's see, we have 3 tubes here that I'm going to transfer them to. We have the major, the minor, and then the recipient control. So the minor is going to be donor plasma and recipient red blood cells. The major is going to be recipient plasma and donor red blood cells, and then the control is just going to be recipient plasma and red blood cells. So I'm just going to take these, I'm just going to take the tops off. Okay, just put these right here. And I have my plasma still here. I'm just going to get rid of these. And I'm just going to grab some more pipettes. Okay. Those. Alright, so I am going to start, let's start with the major. So we'll take recipient plasma, which I have here, and that's going to be 2 drops plasma to 1 part red blood cell suspension, the 3 to 5%. So I'm going to get my donor red blood cells, have those there, and then my recipient plasma. Okay, so I'm going to start with the plasma, and I make sure that's major, yep. Okay, recipient plasma. So I'm going to do 2 drops of these. Okay. And then I'm going to take the red blood cell suspension from the donor, and we're going to do 1 drop of that. Okay. Just do that. So that is our major. It's pretty hemolyzed. Just put that tube on. Alright, so all the major, minor, and recipient white top tubes are going to incubate at room temperature for 15 minutes before we perform the agglutination. So I'm just going to move the major over. So then we're going to do the minor, which is going to be 2 drops of the donor plasma to 1 drop of the recipient red blood cells. Just gonna... We have our minor, so donor plasma, which I have here. Right, so 2 drops of plasma. Okay. To 1 drop of the recipient red blood cell suspension. Just have to do our recipient control, so that's going to be both the recipient red blood cell suspension and plasma. So 2 drops of plasma from the recipient. 2. Okay, and then recipient red blood cell suspension is going to be 1. Okay. Alright, so we have that there too. So we're just going to put these to the side. And again, those are going to incubate for 15 minutes at room temperature, and then we will come back and look at them. Thank you. Okay, so we are back. Our 3 samples have been sitting for about 15 minutes at room temperature. So I'm just going to take a look at these. They're all pretty hemolyzed. The minor sample is not too hemolyzed. So I'm going to go ahead, I'm going to resuspend all 3, and then we're going to spin them down for about 15 seconds. Okay, so I already have a counterbalance tube in. They're all even, so we're going to go ahead and spin these down. We're going to do it the same RPMs that we've been doing it the whole time, the 9,000. I'm going to do this for 15 seconds, so I just have a timer set since ours does not have a timer, so I'm just going to go ahead. And we're just going to... Stop that, and then what we're going to do is add a drop of each to a microscope slide. I already have these slides labeled. I don't know if you can see them right here. I have my major, minor, and the control. So we're going to go ahead and add a drop to those. I'm going to look first in the tube and see if I can see any agglutination visibly, which sometimes you can see, and then we'll also look for agglutination on the slide. If there is agglutination present, that unfortunately means that these 2 animals are not a match, and we would have to keep looking for a donor for our recipient today. Alright, so these are done. Okay, so here's all 3 of these. Otherwise, I'm just gonna move these around. They're all pretty hemolyzed. Alright, so I don't think I see any agglutination visibly on major. The recipient. Not seeing anything there either. And then the minor. I'm not seeing any visible agglutination, which is why we always check with the microscope. So I'm just going to go ahead. We'll start with the major. I'm just going to get a drop of each. So we have major. Take a clean pipette. And major. Getting some air bubbles. Just gonna try one more time. There we go. Okay. Okay, and then we have our recipient control. Okay. And then we have our minor. Okay, so the only thing we need is a cover slip. I am just gonna run out and grab those and we'll be right back. Okay, so we're back. So I just have my cover slips. I just had to grab those. I'm gonna add a cover slip to each of these slides and we'll look at it under the microscope to see if we can see any agglutination. so we're gonna start with, let's start with the control. Take my glasses off. All right. So alright, so I'm not, agglutination is usually pretty obvious. I'm just seeing normal red blood cells, nothing clumped together. Just scan around a little bit just in case. And again, this is the control, so there really shouldn't be any agglutination unless there's something wrong with the dog. Alright, so that one looks good. Alright, now we're gonna do the minor. So I am seeing agglutination already. There's a bunch of cells all clumped together in a bunch of spots. So that's not good for this patient. I'm still gonna look at the other slide, just in case. All right, so that's agglutinated, so that's the minor. And then we have major, so we'll get that one, and then we can record these results in the patient chart. All right, this one has agglutination as well. It's actually worse than the minor slide. So what I'm seeing is just a bunch of red blood cells clumped on top of each other. They're kind of in stacks. Instead of like the recipient control that we looked at was nice and even, it was just single red blood cells floating around, not really standing on each other. And this has just giant clumps of red blood cells everywhere. All right, so we are done with that. All three of those samples were hemolyzed slightly, which can affect results somewhat. I'm just gonna head to the computers and we can record these results in the patient chart. So we're back. We're just going to record our results. So we're in the first patient's chart, which was the recipient Brutus. So I'm just going to note that he was not a match with patient Fozzie. That was the donor, just so they know for future record and we don't have to test them again. So I'm going to type cross match performed with donor Brutus, or I'm sorry, donor Fozzie, number 5567. And agglutination present macroscopically and microscopically, or I'm sorry, just microscopically. Okay, so it's just noted my initials, and we're gonna save that, and then we're gonna go to Fozzie's account. Just note it in both places. So patient had cross match performed, was not a match for recipient Brutus, confirmed by agglutination. Okay, my initials, and that's it. Thank you.